Dear friends, in this video and some of the coming videos we will discuss about t-test in detail. The points to be discussed are: what is t-test, when it is used, how t-value is calculated manually, how t-value is calculated in Excel with the help of formula and functions given in Excel, how t-value is calculated with the help of analysis tool pack given in Excel. Let us start with the small introduction of t-test. Friends, t-test was developed by William Shelley Gaucher in 1908. The test was named Student's t-test initially, but in short it is known as t-test nowadays. It is a non-parametric test for hypothesis testing. It is used to check the significance of difference between two means. It is applied if now the assumptions of using t-test are given. It is applied if data are taken from normally distributed population, subjects are selected randomly and independently for sample, homogeneity is there between the variances of different groups, data are obtained in interval or ratio scale. Now basic formula to find t-value. This is basic formula given by William Gaucher. T-value equals to CR, that equals to in modulus x bar 1 minus x bar 2 minus in modulus mu 1 minus mu 2 upon SED, where CR is critical ratio or t-value. Friends, in some cases it is written t-value and in some cases it is written critical ratio. X bar 1 mean of first sample or first group, x bar 2 mean of second sample or group, mu 1 mean of first population from which the first sample is taken, mu 2 mean of second population from which the second sample is taken. SED, standard error of the difference between means. Friends, generally in null hypothesis we assume that population means are equal. No difference is there between population mean. In that sense, mu 1 and mu 2 will be equal, so difference between them will be 0. So by keeping in mind in this point, the formula is later on taken like this: t-value equals to CR equals to in modulus x bar 1 minus x bar 2 minus 0, means mu 1 minus mu 2 is 0. And 0 does not make any difference if it is deducted from any number. So finally the formula is taken nowadays in this way: t-value equals to CR equals to in modulus x bar 1 minus x bar 2 upon SED. Difference between mean is always taken positive. Now we'll see formula to calculate SED. Different formulas are there to calculate SED in different situation, in different condition. The first condition is when two means are uncorrelated, means two samples, two groups are made from different population and the samples are taken randomly, then the means obtained by from such two samples is called uncorrelated mean. And in that two situations are there. For large sample, means if the number of observation in sample is more than 30, then to calculate standard error of difference between mean, SED, this formula is taken, where SED equals to in root SD1 square upon N1 plus SD2 square upon N2. where SD1 square means variance of the scores of first group, SD2 square means variance of the scores of second group, N1 number of observation in first group, and 2 number of observation in second group. It means when number of observations in sample is greater than 30, then SED is found in this way, and means of both the groups are found by normal formula of mean, and by putting all these value in the formula of T value or CR, we will get T value. Now second situation for uncorrelated mean is small sample. Here the formula is given for small sample. Small sample means if number of observation is equal to or less than 30 in sample, then to find SED this formula is used. Standard error of difference between mean is equal to SD into in root N1 plus N2 upon N1 into N2, where SD is combined standard deviation here, and it is found by using this formula. SD combined standard deviation, remember here SD is combined standard deviation, and it is found by using this formula in root sigma x1 minus x bar 1 whole square plus sigma x2 minus x bar 2 whole square upon n1 minus 1 plus n2 minus 1, where n1 is number of observations in first group, n2 is number of observations in second group. Sigma x1 minus x bar 1 whole square equals to sum of the squares of the deviations taken from mean of first group. Means from each observation of first group, the mean of that group is deducted, that is called deviation, and their square is taken, and the sum of the squares of the deviations taken from mean is called sigma x1 minus x bar 1 whole square. In the same way, sigma x2 minus x bar 2 whole square equals to sum of the squares of the deviation taken from mean of second group. Now, second condition, we have seen the formulas to calculate standard error of difference between means when two means are uncorrelated. Now we are going to see when two means are correlated. In three situations, two means are said correlated. Situation number 1 is pre and post test scores. When pre-test scores and post-test scores are taken and their means are to be compared, then such two means are called correlated means. And situation number 2, if two groups are taken and both the groups are made by matching pair method, matching pair sampling method, then the means obtained by two groups are called correlated. In these two situations, the following formula is used to find SED. SED equals to in root sigma 1 square plus sigma 2 square minus 2 into R into sigma 1 into sigma 2, where sigma 1 is SE1. SE1 means standard error of the mean of first group. That is found by using this formula SD1 upon N1 in root N1. SD1 means standard deviation of first group. N1 is number of observations in first group. Sigma 2 is SE2, standard error of the mean of second group. And it is found by using this formula SD2 upon under root N2, where SD2 is standard deviation of second group and N2 is number of observations in second group. And R is correlation coefficient between the scores of both groups. We have to find here correlation coefficient also when two correlated means are given, then R is used there. And in these two situations of correlated means, this formula that is seen on the screen is used to find SED. By finding SED in this way, and by finding means of both the groups, normally all the values are put in the formula of t value or CR and t value is found. Now third situation for two correlated means is two groups are statistically equivalent. If two groups are taken, they are not taken randomly, but both are made equivalent by using some statistical technique, then the means obtained from such two groups will be called correlated means. And in this situation, when two groups are made equivalent, then to find SED, this formula is used as shown on the screen. SED is equal to under root in bracket sigma 1 square plus sigma 2 square bracket over into in bracket 1 minus r square bracket over. Sigma 1, as we have discussed earlier, SE1 standard error of the mean of first group. It is found by using this formula as we have seen earlier, SD1 upon under root N1. Sigma 2, SE2 standard error of the second group. It is found by using this formula, SD2 upon under root N2. And R is correlation coefficient between the scores of both groups. Friends, by finding SED in this way and the means of both the groups by using normal formula of means, all the values are put in the formula of t value or CR, and we will get t value. So in this way, we have seen different formula to find out SED in different condition, and basic formula for t in this video. Now in next video we will discuss about how to calculate t value manually.